Well done.
Well, yo.
Are you bothered?
I don't give it a shit. That's it. Where's it gone? Oh, is it?
He's going to his phone.
Thank you.
Good right, so. Well, thanks everybody. My name's Robert, M0NVQ, and I've been working on this talk for quite a while, and I did part of it as the construction competition. When did COVID start? 2020? 2020. So I put the pictures in and a bit of it in Radcom, and I came third or fourth. I got the yearbook, so I was quite pleased with that. So I hope people find this relevant. I've kind of produced this really intended for beginners, M6s, M7s. So if you get anything, obviously, if you pick anything up out of it, park it, keep it and use it, and otherwise I'll let you know when I finished and you can wake up. But when I first started, when I got my foundation, you know, you get a handheld, or you get an 817 with an antenna on for 2 meters and 77s, and it's a shack in the box. It works and it's clean, and there's no messing about. It just works. And then you try and go on HF, and it starts to get
a bit tricky.
A bit tricky, because everybody knows that there's no sort of perfect antenna for everybody, so you end up fettling and making something that's suitable for yourself. So, and it's not a black box and antenna that comes together and works straight out the box as per the manufacturer. So one of the things that you end up trimming antennas, and you end up messing about it, especially when you got your full license. You're messing about with kits and building transmitters and things, and you end up starting to think about how to protect the radio, because you could destroy your radio because it's not just a straight out of the box working thing. I made a list of some of the radios that haven't got a built-in antenna matching unit, and it's probably a much longer list than this, but the 817 and the 818, although they've got the power foldback, but they haven't got a matching unit in them, so you could theoretically sort of short the antenna while transmitting, and probably wouldn't do it very good. There's things like the Ubitex V6, the Indian radio that was a kit, which was in Radcom about 6 months ago. That's got no antenna matching unit. The QRP Labs, the Hans Summers, is it G0UPL, I think it is, he's in Turkey, but he makes great kits, but there's no antenna matching unit. There's a Lab 599 which has been reviewed. The ICOM 705 hasn't got a matching unit unless you put the separate one on. The ASU 891. The ICOM, even the ICOM 7200 hasn't got an antenna matching unit. So in my mind, I was starting to think about.
I thought the 705 did.
That's that little portable thing,
Yeah.
the 705, isn't
But
it?
it needs a 705 ATU to go with it, the AH705.
Right, I thought it was built in.
So this started to make me think about not damaging the radio. I started to experiment with antennas, inverted V's. So the Bilara, who at the Norbert, at the NASA Norbert Valley, Bilara have a great inverted V, which is also on M0UK. Oh, what's his call sign? There's a great website with a calculator on it. UKD, M0UKD, he's got a calculator for inverted V's, but you're still not 100% sure if you're putting your transmitter at risk. After I built the 40 metre, 15 metre inverted V, I tried to use it as a fan antenna with a 20 metre inverted V at the same time, and the SWRs were going wild, so you stop press to talk, but you still think, what am I doing? I'm just relying on, in the case of the 817, relying on the foldback, and it started to worry me. So, but I did know the inverted V worked, and so this is the Bilara one for 40 metres, and it did work a treat, but the weight of the coax pulls the fishing pole over, and of course because I got caught in the rain once, so I put it in a vitamin C bottle, and the water never got in, but the thought occurred in my head that when you screw the cap on, if it twists and shorts the wires at the top,
Yeah.
you know, that's a sort of a bit of a mistake to make. So I just kept thinking over this problem of how do you protect the transmitter, and I got fed up with this coax contraption, and I tried a random wire end fed, because then you've just got a single wire. And the difficulty I had with that, I know it was a common mode current problem, but I had the GQRP Club matching unit for the random wire, and I could get the antenna to match, but the SWR meter next to my radio was showing a wild SWR, and it really concerned me. I got loads of fans out, fanned counterpoises, and my plan was I'd take this antenna to somewhere quiet in the country like I did with the inverted V. But I thought this is not going to be long, not going to be quick to set up, and I've got nothing protecting my radio. And then I stumbled across the idea of the Wheatstone Bridge, which fortunately the GQRP Club have looked at thoroughly. And so what I wanted to talk about tonight was the Wheatstone Bridge, which is a really simple circuit, but it's twice in my career it's proved to be really useful. So when I was at school doing my O-level physics, the physics master said, there'll be a question on the Wheatstone Bridge in your O-level paper, do that question, because if you've seen the question from the past paper, you can't help but get it right, and it's just easy marks. And it stuck with me, and it's popped up in work as an electronics engineer on multiple occasions. Most people, I don't know if anyone's messed about with Wheatstone bridges, but
No.
no. So essentially, it's a potential divider and another potential divider, and you can use it for measuring resistance, but it's just amazing how useful it can be for measuring resistance. I only do up to 10, because then else you have to take your socks off to count past 10. So 10 volts and 50 ohms, those are familiar, and you can use it to measure or check the resistance of a resistor. And normally you would say this is the resistor under test. So if you've got 50 ohms and 50 ohms there, 100 ohms, current flowing through here, this point is at 5 volts. And the same current flowing through here, 100 ohms, 10 volts, so it's 0.1 amp, this point would be at 5 volts. So if that resistor is 50 ohms, there'll be no current flowing through here. You put a limiting resistor in, because otherwise you can blow the meter up. Start off with the high resistance and then wind it down. So you could use this kind of circuit to, if you were trimming resistors, it would end up trimming dipoles. Going to be useful on the third slide. So when I first came across the Wheatstone Bridge used in anger in industry, I worked for chloride batteries. And I'm going to hold this one, so I'll put the calculation up to higher. The chloride batteries were using high current traction batteries for milk floats and stuff. And you wanted, when you were testing the batteries, you need to measure high DC currents. And you can't measure 100 amps, as an example, with an AV08, because its maximum range is 10 amps, so you use a current shunt. So if you took 100 amps through a 20th of an ohm, 0.05 ohms resistor, just as an example, you get 5 volts across the resistor. So you could run a milk float battery on a motor. When the milk float first starts, it draws high currents, and you want to know what the peak current is so that the wires don't melt. And you just measure the voltage across a current shunt that's in series with the battery, and you know how much current you're drawing. But as you will appreciate, you know the old moving coil multimeters, when you short the leads together and zero it, the actual resistance of the leads is possibly more than a 20th of an ohm, so you wouldn't make a current shunt with a multimeter, you do it with the Wheatstone Bridge. So on that example there, I had 50 ohms and 50 ohms, and the voltage was 10 volts, so it's half. You can do it on a milk float, a shunt for a milk float. You want to measure a 20th of an ohm. If you had 50 ohms and a 20th of an ohm, and you had 1,000 ohms and 1 ohm, I can't do hard maths, so I've used 10.01 volts for the battery, just so that numbers work. You have 10 milliamps flowing through here, and that's got the same voltage as 0.2 amps flowing through here. It's still 0.1 volts on both sides. When we used to make the shunts, a current shunt looks like a piece of resistive metal with the ends welded on for the terminals, and you saw through it, making slits in it to make it, the resistance go up with a hacksaw and then with a needle file until you eventually get the current down to 0, and you go, yes, right, that's 20th of an ohm, that's 50 ohms, these two are standard resistors you bought, and you got it to work. So it's a really useful circuit, trimming amateur radio. So you can use the same circuit, or a very similar circuit, for AC, which is why I used 50 ohms in the first sketch. If you've got your transmitter, you use 50 ohms and 50 ohms and 50 ohms and an antenna, you would think that these would be at half voltages and there should be no current flowing through the middle, if the antenna is right. Just point out, this isn't actually measuring SWR, it's only balancing the resistive element of the antenna. If you made an antenna that was just a capacitor, it wouldn't work. You need to be something close. But if you built the antenna like this, and the wire had snapped, so you've only got the 250 ohms, 100 ohms, a 50 ohms radio would see an SWR of 2. If you've got a short on the antenna, on the coax, you've got 100 ohms in parallel with 50 ohms, which is 33 1/3 ohms, which is an SWR of 1.515. So most of the radios that we looked at on my list can withstand an SWR of 2. So if you put the transmitter on a Wheatstone Bridge and trim the antenna, the worst that the radio is going to see on a reasonable antenna, something that's a genuine antenna that you're adjusting, the worst the radio is going to see is an SWR of 2. So it's a really useful circuit. So the GQRP Club has done a lot of work on this, and there's something I should point out about this. If you had the meter in the middle and the resistor to limit the current so you don't blow the meter while you're transmitting, as you come near with body capacitance, as your hands move near, it could affect the meter reading. So I've got handouts of this one, and it is on the GQRP Club website. But they've come up with a circuit. Obviously it needs a diode in it because it's an AC current now. So maybe you're setting the antenna up at 7 megs. But it's basically a crystal set to drive the meter, but it's referenced to the ground of the coax, not to those two middle points. And the circuit works a treat. So I built one, and as I say, I know the circuit works a treat. And it does work. The way that they suggest in the build, the way I've copied it, is when I've got my switch setting in 1, this wire's open circuit. So I know there's only 100 ohms, so the SWR is 2. And then, do you remember in the other circuit there was a variable resistor? I just tweak the pot to give me a full scale reading of an SWR of 2. And then I put the switch in the middle position, which shows I've got my resistors and the antenna. The radio should not see an SWR worse than 2. I can trim the wires, so that wouldn't be on there. The radio goes in there and the antenna comes out here. It's a crystal set basically. These are it's difficult to buy 50 ohm resistors, so these are two 100 ohm resistors in parallel, two more 100 ohm resistors in parallel there, and two more just in there, just there, and these, where's the drawing? Oh. Over here the drawing, the two capacitors are the two yellow capacitors here, and you've got the switch in the middle setting, so the antenna's here. The worst the radio can see is an SWR of 2. If your antenna was shorted, your radio would see an SWR of 1.5. If your antenna was open circuit, the wire would come off the end, your radio would see an SWR of 2. And then once you're happy, turn the switch over to position 3, and it just goes direct to the antenna, missing out the resistors. And it works an absolute treat. And it's just a few components. The it isn't on the menus on the GQRP website. You can't find the circuit by going through the menus at the top of the page, but if you Google GQRP Club Resistive SWR Bridge, it takes you straight to the PDF file. And that's it. And my thoughts are that if you were setting out as an M6, M7 and you were a bit apprehensive about, you bought the first radio, you're a bit concerned about blowing up the output stages. The old 817s, not the 817NDs, I don't think they had output protection on.
No, they didn't.
And you get a lot of people buying the trannies for them. But if they'd used a protective circuit, then perhaps they wouldn't have shorted out the transistors.
The ND and the 818 fold back, don't they?
They do. My 817ND folds back.
I don't know what it folds back to, but...
So I was setting up in the garden, because the inverted V with the weight of the coax was bending the fishing pole. I was setting up the end-fed, random wire end-fed, so it's not resonant on any of the bands, and a counterpoise fan on the back lawn. I was hoping that if I got it to work, when I go out in the country on an afternoon, I would be able to get it to run. And even though the SWR at the base of the wire at the 4-to-1 transformer was low, it was high on here, and I had a separate SWR meter as well as what's in
the internal one's useless.
No, but it does give some indication.
It gives you an indication, but that's about it.
But both of them were screaming, the radio was folding back. I know I had ground currents and I just never got the counterpoises to work. But it just, if I'd have done that on my other radio, the kit one I built, the outputs would have just gone.
What did they fold back to, do you know?
I think it goes down to the minimum power, doesn't it? Is it 1 watt?
1 watt?
Yeah.
No, it's
half a watt.
Half a watt.
Oh, the other thing to mention, which I should have mentioned on this circuit, is if you've got the antenna on and it is 50 ohms, or nearly 50 ohms, you'll have spotted if you're putting out 5 watts from your radio. So I recently bought an SWR meter that had a max on the most sensitive range. It was full scale at 2 watts forward power. But the SWR meter I had before, it was only any use over 5 watts, so it's difficult to use with an 817. So I had to use the 817 at full power. But a quarter of the power goes in this resistor, a quarter in that, a quarter of the power in that one, and 1.25 watts going out here. Now I know you're supposed to call your call sign out, aren't you? But when a lot of people, when they're setting up their antennas, they just seem to beep. But if it makes your conscience feel any better, you can use your transmitter at 5 watts, knowing you're only putting out 1.25 watts here. If you're matching, I know you still should give your call sign, and that's your apprehensive about the antenna, but at least it's not that bad.
No.
Whether it leaves your conscience clear or not. I mean, if you use a nano VNA out of band, you know, you've never done it, but but then that's only like a milliwatt. But you know, it depends how clear your conscience is, doesn't it? So, but it's a great circuit, and there is a fantastic. If you go on, I bought spare copies. But if you do Google for the GQRP Club's resistive SWR meter, you get the circuit, you get an explanation of how the circuit works, and providing you keep the wires fairly apart, not too close together, well, that definitely works on 80, 40, 20 and 15. It's probably good on 10, but by then you're starting to get capacitance effects, but it's probably alright. So when I built my resonant end-fed antenna and my Fuchs antenna, at that point I was starting to get concerned about protecting the transmitter circuit, and this was just excellent to have. Obviously I don't take this around, I use this, what I do is I try my antenna at home on the lawn at the back, very small lawn, but I get a fishing pole up, and when I'm happy that things are okay I don't bother to take that with me. I just, once I've finished fettling with this and I've closed the lid and I'm satisfied it's not shorted inside, I don't take that out in a backpack or anything, but
No.
it is handy when you're fettling.
You could construct that to a much smaller scale, couldn't you?
Yes, you could do, yeah.
Yeah.
It's a bit of a jungle with the wires crossing over, but yeah, it would be possible to make that a lot smaller.
Yeah.
Yeah, you could, couldn't you? Yeah.
That's the wood, the model aeroplanes make gliders and things, and the plywood.
It's just thin ply, that, isn't it? Yeah.
They use it for the fuselage,
Yeah.
the bulkheads, and railway modelers use it to make tunnel entrances and exits on railways.
It's just 2mm ply or something. Yeah.
2mm ply, it's dead cheap, and you can cut it with a Stanley knife and a ruler, and that's what I did during COVID.
Well, it'll give you something to do, doesn't it?
COVID lockdown, because I haven't got access.
That antenna you've made there, what's that? What band is that for?
14, 15.
14, 15.
Because
How long's that?
it's 63 foot 3 inches. It's 19.3 metres. It's 10 metres each side. So it's
Yeah, too long, you couldn't use that.
1/4 wave for each side, but it's 3/4 waves on 15.
Yeah, right.
And it does give a low SWR on that, or on an SWR meter.
Yeah, so it's quite big, isn't it? Quite a long antenna.
Yeah, it's but there's no way of shortening it without putting coils in, is there?
No.
But if you've got a Sota Beams were selling, I think they've still got them, a 10 metre fishing pole.
Yes, they do. Yeah.
And if you've got 10 metres of wire, 10 metre pole and 10 metres of wire coming out at 45 degrees to the vertical, the ends, you need string because the ends don't reach the ground.
Oh, yeah.
And I found it work, if you can get away from the house, it's great. Go somewhere National Trust or Stanage Tunnel. There's
There's no thickness in that wire at all.
Sota Beams is wire. So.
And I presume there's no weight in that bottle.
No, it's just a vitamin C bottle.
So a fishing pole or some sort of telescopic pole will be alright with the weight of that, wouldn't it?
It's the weight of the coax that's the problem.
That's the problem.
Which is why I've now switched over to the resonant end fed, where instead of having 9 metres and 9 metres of wire.
Well, they do some ultra thin coax. Have you seen that they use on the Aerial 51?
I have seen them.
Very, very thin coax.
What's
Very,
the-
very light. And I can't think of the name of it.
But I then started to go down this route of, because this is a half-wave wire. If you feed it at the end, you don't have to support the coax.
No.
Which is why I went down. So I think is it next week? Next week, which is shorter. Well, that wasn't too bad, was it? But
No, that was
minutes.
good, yeah.
But the end-fed wire is much easier to set up because this is Sota Beams' wire. It doesn't seem to stretch,
No.
and it's still the same length for half wave on 40 metres, but it's you're not supporting the coax.
No, that's true. Yeah.
And you can still use this box to debug the matching unit at the base of the end-fed half wire, so I didn't feel as if I was at risk of damaging. I can't guarantee.
You always worry, don't you, with these? Because the finals, obviously, because it's only a 5 watt rig, 6 watts or whatever.
when I bought my 817, I thought this is the first and last radio I'm ever going to buy. I'm going to look after it. And now I've got a shelf of them. But even so, you still don't want to.
No.
You still don't want to mess
What's
it
the
up.
maximum power on the 817?
5 watts.
5 watts.
This is the 818, which is 6 watts.
6 watts. We've got up one.
When they brought this one out, we increased it by 1 watt.
Which is negative.
But if you're using 2 watt resistors, 2 100 watt resistors in parallel to give you your 50s, you've got 2, 4, 6, 8, 10, 12, 14, 16 watts capability.
Yeah.
And what I sometimes do, if I'm not messing about with antennas, I'm checking a radio. So that's another 2 100 watt. Instead of having the antenna on, I just put that on.
Oh right, I see. Yeah, I got you.
And this box is now, just ignoring the meter or anything, this box is 50, 50, 50, 50, so it's a 50 ohms dummy load,
Gotcha.
16 watt rating.
Yeah.
16 watts is still 16 watts, so when you touch them they're still warm, but
I wondered what
don't
that.
touch them.
Yeah, I've got it now.
But that's theoretically 4 watts, because it's 2, so I have actually run it on the back.
What was a dummy load?
Yeah, but I wouldn't do it for many minutes because they do get hot.
Oh yeah. Yeah.
Well, at least if you do them on the back, don't touch them.
No.
But
I mean, these are really good radios when you
Yeah.
get them out in the field. They're
Yeah.
fantastic.
Well, they're field radios, aren't they, really?
Yeah.
Yeah, you can use them in the shop.
I mean, I've worked 5 and 9 Bulgaria on that on 5
Yeah.
watts,
Yeah.
and that's with a piece of wire shoved in the back into a loop.
Yeah.
how did you match it up?
It had a matching unit.
Oh right, yeah.
It's a loop that attaches to this little box, and what you do, you put it in the back,
Yeah.
and you turn the dial so you hear the most noise for the band. It marks off
On
the
receive.
bands on receive,
Yes.
Yeah.
and it gets you in the right ballpark.
Well, ATU works a bit on it.
Yeah.
You can work your ATU that way, you get the maximum.
Because I couldn't believe it. I was sat in the garden, not last year, I think it was the year before during lockdown, and I shoved this thing in, and I was having a beer in the back garden on a nice day, listening. And I heard on 20 metres this guy, and I thought, where's he coming from?
Over there.
And I got the LZ bit, and I went back to him, and he come back to me.
So next week,
Yeah, it's interesting.
next week I want to talk about the
Send me a copy.
Fuchs and FUCH Fuchskreuz antenna, which overcomes the problem of the weight of the coax.
Yeah.
But because I was a bit apprehensive about it, I used this box. That's really why I bought this box, was to protect the radio. I knew
Yeah.
that the Bilara, I knew the Bilara ladies antenna worked as a single dipole for 4015, and if I put a dipole up for 20 metres at 90 degrees, I could get it to work, but it wasn't always perfect for the SWR.
Yeah.
But I wasn't too worried. But when I started to experiment with the Fuchs, I thought I'd build that. And
You'll be thinking.
I got a free book from the RSGB, the yearbook. So,
Yeah. Nice. Well,
Was
I don't-
that not used in, I think I remember that being in the RE though. That's the question on that bridge.
Wheatstone Bridge.
Yeah.
Sorry, I've got one.
When I first did the RE,
IE, yeah.
there was a question on, we went over that.
It is just such a great circuit. I mean,
it looks quite simple as well.
yeah. I mean, that's the biscuits. It's.
Even a Luddite like me could make one of them.
I mean, when I was working at chloride batteries, the difficulty in measuring battery currents, but all the engineers were making their own shunts
Yeah.
to measure the current, and the shunt is that Constantin metal stuff that's resistive metal, but it's got a very low coefficient of change of resistance with temperature, and it'd be a piece of metal like that with 2 big copper straps on each side grazed on, and then you'd hacksaw through it. You'd start off with a very low resistance, and you keep hacksawing through it in a zigzag pattern to get the resistance up to what you want. If you go past it and this voltage is higher than that, put it in the bin and try another one. But we used to be doing them all the time, you know.
I remember it was a question that came up in one of the, we got over that.
So, yeah, it was used.
But whether it's in the latest version, I don't know.
I think I passed my O-level physics on the strength of that question.
Yeah.
Anyway,
Thanks very much.
Yeah.
hope you enjoyed it.
Yeah,
Anyone that
interesting.
already knew that stuff, you can wake up now. I finished.